Hi, my name is Carly Beckhoff, and I'm going to be teaching you guys how to solve a problem connecting density and the ideal gas law. So the problem says when HNO3 aqueous and NaHCO3 aqueous are mixed together, a reaction takes place in which a gas is one of the products. The gas has a density of 1.83 grams per liter at 1 atm and 23 degrees Celsius. What is the molar mass and identity of the gas? Okay, so you know that the reaction is HNO3 aqueous and NaHCO3 aqueous, and then it forms a reaction. You also know that the density of the gas is equal to 1.83 grams per liter, and that the pressure is 1 atm, and that the temp is 23 degrees Celsius. But you're going to want it in Kelvin, so you're going to add 273, which is then equal to 296 Kelvin. So you're going to be using the ideal gas law, which is PV equals nRT. So it's important to know that R is equal to 0.08206 liters atm over moles Kelvin. So you have your equation here, and then you also have density. You know that the equation for density is equal to mass over volume. So you're going to want to manipulate your density equation so that the V, the volume, and the V here can replace each other. So you'd multiply by volume on both sides for the density equation, which would cancel out here. So then it'd be volume times density is equal to mass, and then you divide by density, so you get volume equals mass over density. So then you take your mass over density and put it back into the PV equals nRT equation. So you'd have pressure times mass over density is equal to nRT. Then, once again, you multiply by density on both sides. So you get pressure times mass is equal to nRTD. You're then going to want to divide by nRT. So you get pressure times mass over nRT is equal to density. But then you see you have mass and you have mole, so you can use those two and make it the molar mass. So you have pressure times the molar mass over RT is equal to density. You're going to want to do that using the numbers you were given. So now you know that you have 1 atm for pressure, so it'd be like 1, and then the molar mass is what you're trying to find, over R, you know, is 0.08206, and temp is 296. And then you know from the given that the density of the gas is 1.83, so you set your problem equal to 1.83. So then you'd multiply the numbers on the bottom to get the molar mass over 24.28976 is equal to 1.83. You're going to then cross multiply to get the molar mass to be 44.5 grams per mole. So going back to your original equation, you're going to try and solve, like, the molar mass you just found is the molar mass for one of the products in this reaction. So you're using what we've already learned in chemistry. You would know that the products are NaNO3 plus CO2 plus H2O. So if you look at CO2, you know that the molar mass for carbon is equal to 12, and the molar mass for oxygen is equal to 16. So if you do 12 plus 16 plus 16 for the two oxygens in CO2, it comes out to be 44 grams per mole, which is very close to the 44.5 grams per mole you found here. So given that, you know that the gas that you have the numbers for would be carbon dioxide. So just a quick little recap of what I did. You have your given numbers. You're gonna convert your density equation so that you could use the volume to find the volume and put it back into your PV equals nRT, which is the ideal gas law. You're then going to plug in the numbers and solve for the molar mass. Figure out your products and calculate to see which one is the closest.